Okay, good afternoon, everybody. So, first of all, about presentations, you know that we moved, we changed the presentation date to Monday, April 25th, which is this coming Monday, and the Monday after, May 2nd. I know, like, most of you wanted to do it earlier on 25th, but we only have 1 hour, which means like 5 groups. And I randomly selected 5 groups to present on 25th. And then the remaining groups will be presenting on May 2nd, okay? And so first group, this is another group for 25th, this one, and these 2 groups, okay? Okay. If you are presenting on 25th, so you have to be in class on 25th for the entire time because you need to kind of like evaluate other presentation. If you are presenting on this on the 2nd, May 2nd, you need to be in class during the presentation time to grade basically other presentations. Okay, but if you are presenting on 25th, you don't have to be in class on 2nd and vice versa. Okay? In some sense, people presenting on 25th are sort of lucky. Yeah? Maybe not. Yeah, go ahead.
Just to reiterate, so you only have to come to class when you present, you have to stay for the whole time.
Yes, exactly. Okay. Any questions about the logistics? So presentation basically would be around 10 minutes. 2 minutes for Q&A and kind of like transitioning to the next presentation. So only 10-minute presentation. So we basically just prepare accordingly. Not too many slides. Okay, Minitab. I told you how to use Minitab for doing analysis of variance for 2 factors for 1 factor and 2 factors without interaction. And I figured out what the problem is. Actually, in each version, they have a new way of inputting the data. So now I want to show you how to do analysis of variance for 2 factors when you have interactions. Okay. So stat, ANOVA, general linear model, fit general linear model. So this is your response. You have 2 factors. One is temperature. The other one is glass type. Okay? Yes. Oh, yeah. Let me ask you that. You cannot see it from there. This is cool. Turn on this screen over there. There's a screen here. Yes. It's broken? Okay. It's broken actually. So let me see.
I mean, there's an entirely empty front row that people can move up.
Yeah, actually, you guys can move to the front row. That's a good idea. Because I cannot increase the resolution here. So in order to define the interaction, so we have the factors like temperature and glass type. We go to model, and here, apparently, we need to select these 2. Okay? Oh, it's already here. But let me remove it. So we select these 2, and then here it says interaction order 2, which is the interaction of these 2. Then we push add button. Then we get the interaction between temperature and glass type. That's it. Otherwise, you don't see any interactions. Okay, and then, okay. Did I talk about the residual plots? or not? I didn't. Okay. So basically, as you can see, now the ANOVA table that you have includes interaction with the corresponding degrees of freedom, sum of a square, and you have the p-value. Okay? You can have the coefficients, and as we discussed before. And one thing else is, you remember for analysis of variance, we had some assumptions. Data should follow a normal distribution. Variance should be constant. And what? Residuals should be independent. And you remember we had some plots for that. So you can basically, if you go to graph and then 4 in 1, it gives you those plots, residual plots for checking the assumptions. Okay? Dummy variable. So for now, like, I'm not doing regression, but if you want to do dummy variable for regression, you go to coding and you define your dummy variables here. Okay? Graph again, you can 4 in 1. It gives you all the residual plots that you want. And here is the residual plot. So it's sort of normal distributed. The variance is constant. And this is the normal plot. And this is sort of to see if you can see any non-random pattern. So the assumptions are, I would say, valid here. If you want to do a statistical testing, you can do normal hypothesis testing for residual. How? What you can do here, you can go to a storage. So push the storage button and say, okay, residual. So what it does, it saves the residual values in one column. You can see? Residuals are stored in one column. Then, if you want, you can perform normality tests for residuals. Again, this is very important. In your projects, don't make this mistake. You cannot perform normality test when you are doing an ANOVA regression. You cannot perform normality tests for Y. It should be based on residuals. Okay? Why is that? Because let's say in ANOVA, this is the hypothesis that you are testing. Otherwise. Okay? So if H null is not true, you have different populations. So you have maybe this is mu1, mu2, and mu3. Okay? Since they have different mean, if you pull all data together and do the hypothesis testing for normality test, it's going to be rejected because means are different. So you can see this is one normal distribution separately, this one normal distribution separately, this is normal distribution separately. But when you put everything together, it's not going to be normal. Because you are not adding up, you are just pulling the data together. But when you are calculating residuals, what you are doing is you are scaling all these different, you are removing all these differences, and everything should be around 0. Because residuals, the mean of residuals is around 0. Then you can pull everything together. Okay? So I can do the residual test for basically the normality test for residuals. And as you can see, it's not rejected. We have a little bit of problem in the middle, and it's clear from the histogram. I cannot find the histogram, but anyways, you saw that the histogram has a very odd mode. How about testing the variances? You remember I told you the variance should be constant. If I, oh, not here. See if I can find it. Yes, here. So that's the problem with the histogram. So here. So variances are sort of constant here. But what if I want to perform a hypothesis test to see variances are constant or not? So I can basically do this hypothesis testing. So it's sort of like ANOVA hypothesis testing, but for variances. Okay? So stat ANOVA test for equal variances. Okay? So you know how to perform when we have only two. This is just an F distribution. But here, when you have more than two, you select this option. So this is your response, and these are the factors, temperature and glass type. Okay? And all are in one column. And for a hypothesis test on variance, you can select the response is not necessary to use residuals because it basically it asks for factors, so it takes care of the difference between means. In options, you have two options actually. If your data follow normal distribution, you select this one, and it does basically it performs a test called Bartlett test. Otherwise, you remove that one, and it performs a test, a non-parametric test called Levin test. So as you can see, this is the non-parametric when the data is not normally distributed. P-value is 0.325, so we cannot reject X null. Therefore, variances are constant. Okay, and for this one, you can see this is Bartlett test. Again, p-value is 0.09, so variances are constant. Okay? Any questions? We good? Yes?
Isn't there also same variances
Yes.
as well?
Yes.
Same test?
Yes, you can do the same test, yeah.
So what is to do the Bonferroni correction? Is that or output from this?
So here you mean?
Yes.
It doesn't do individual tests. This is kind of like all together. Here are the individual tests. So if you want to do individual tests, which is basically for all combinations, you find the standard deviation, you find the confidence interval, and see if they overlap or not. So then you need to basically have a correction factor for Bonferroni, okay, like Bonferroni correction factor or other stuff. But this one is not pairwise, it's all together. So it's not performing tests for this and this or this and this or this and this. It's like all together. It's the difference between like two sample T and ANOVA, something like that. Yes?
Do you have to have the same sample sizes, or does it automatically?
I don't think for this, I don't think so. I'm not sure. I'm not sure. But I don't think so. I mean, you don't have to have exactly same sample sizes. Because we are using, yeah, I don't think so. But double check. Your problem, I think you don't have balanced data. Am I right? So, yeah. No, you can if it's unbalanced data using general linear model. You can analyze the data. That's fine. But in terms of Bartlett test, I don't think there is a problem. But you need to double check. Yes.
Confused. Can you go back up to the data and kind of which variances is the testing and how are those all the same?
Oh, the variances are like how many combinations do we have? We have basically, let me show you. Where's the data? Oops. No, actually, all combinations, not the replications. I'm trying to find the data what we have. I guess, oops. Data furnace. No, it's the output part.
Oh.
Should be not this one. Maybe this one, yes. So you can see how many combinations do we have. Like for temperature, you have 3 levels. For glass type, you have 2 levels, 1 and 2. For temperature, you have 100, 125, and 150. So 2 times 3, you have 6 combinations. So basically, you have 6 combinations in your data table. You have basically this. So you want to see if the variance of this group and 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 this group are the same. So what we are doing is if all variances are the same or not for each combination. And this combination means 100 and type 1, type 2, 125, 150. Okay? That's what I mean. And inside that you have replications. Okay? Okay. Any questions? So regression. For regression, you can do different type of regression. The one that you learn in this class and some like more advanced regression models. But what you can do, if you have only one variable, y versus x, for example, then you can select your response, select your temperature. Let me see if it has, yes. You know the assumptions. If I want, I can check this 4 in 1. And the model, if I want to have linear, quadratic, or cubic, okay, then that's it that I get. So this is linear. So linear model, you can see regression. This is the analysis of variance for regression, whether beta 1 is equal to 0 or not. And this is R square adjusted, and this is R square, and this is the regression model. Okay? So, as you can see, residuals are acting kind of weird. Okay? So, one reason could be we are not considering one variable, which is class type. Okay, that could be one of the reasons, or we need to include a higher order. If I do that, it doesn't improve, but what happens is I have a better R square adjusted. So it's 80% here. For linear, it's 72%. Okay? Again, it has a problem. It's not good. And you can see some of them are here, some of them are here, some of them are here. This could be because of the fact that we haven't included class type. Okay? What if I want to perform regression for 2 predictors? And let's say one predictor is continuous, numeric, and another one is basically categorical. So stat, regression, regression, fit regression model. Select this one. This is our response. And we have one continuous predictor, which is temperature. So actually, it should be something like this. Temperature. And then one categorical, I input class type. Coding, I want to use basically dummy variables, 1 and 0s, which we know how to analyze. And for model. So here, if you want to have, let me just remove everything. So if you want to have only linear, you just double click on this. It gives you linear. If you want to have interaction, so this is for interaction up to order 2. You select that, it gives you interaction. If you want to have quadratic model, then it says term through order. This is 2, which means quadratic. Then you select this one. Oops, sorry. Yes. You can see for temperature, we have quadratic order. It didn't give us class type quadratic order because, you know why? It's categorical. Yeah. And this is for the case that you want to have intercept in the model. And if you want, you can have your residual analysis, then push OK. So as you can see, this is the residuals. It's a little bit better. And these are regression, basically, this is the basically regression analysis. So we have this ANOVA table, the first p-value is for regression, which is basically whether beta 1 is equal to beta 2, beta k. All of them are 0. This is H null, and H alternative is otherwise. Remember? So that's basically the F test that we had. The p-value and this F value corresponds to that one. So whether all coefficients are the same and all of them are 0 or not. Does it make sense? How many coefficients do we have? We have one coefficient for temperature, linear, one for glass type, one for quadratic temperature, and one for interaction. And one for what? Intercept. But intercept does not, actually, we do not include intercept here. Okay? So how about these F tests? This is for testing whether the coefficient corresponding to temperature is significant or not. This is for testing whether the coefficient corresponding to glass type is significant or not, and so on and so forth. So what we learned in class wasn't F test. It was for individual coefficient. It was, you remember? T-test. Okay? So for testing whether beta k is 0 or not, we use t-test. But we know that t squared is, with n degrees of freedom, is f1 and n degrees of freedom. So that's the relationship. So instead of doing t, they're using f, but there is a one-to-one relationship between f test and t-test. You can do either. Okay. So there is something called lack of fit. Okay. So basically it says whether the model that you are fitting is a good model or not. Okay. So the H null says it has a lack of fit. H alternative says it doesn't have a lack of fit. Okay. So we want to reject H null. In this case, you can see H null is rejected, so it's a sort of good model. Okay. You cannot perform this regression, like lack of fit test for all regression problems unless you have replications. So by replication, I mean at least for one of the x's, these are the x's that you have data. So if your regression is something like this based on these 4 data, you cannot perform basically lack of fit test. It should be something like this. You know, some of the x's should have replication. So more than one observation. Otherwise, you cannot basically perform. So R square adjusted is 96%. Do you remember when we didn't have basically our glass type in the model? It was around 75, 76%. Now it's around 96%. Actually, it's pretty good. And these are the regression equations. Okay? So if glass type is 1, then actually we had 3 glass types. I thought we have only 2. But anyways, if glass type is 1, this is the regression model that you are using. If glass type is 2, this is the regression model. And if glass type is 3, this is the regression model. This is sort of like combining, separating based on the dummy variable that we have. Okay? So instead of using dummy variables, what it does, it gives you 3 separate equations. And if you want to, if your glass type is 1, you use this equation. If it is 2, this equation. And if it's 3, this equation. Any questions? Yes? Yes, that's correct. But this is R square adjusted. This is our regular R square. This is our regular R square. This is R square adjusted. And I don't know what this is. R square prediction. I don't know. Okay. So what else? Last one is logistic regression. So what if we have a y variable which is categorical? So let's say we have Y as resting pulse for basically heart, and we have, this is Y variable or response. We have two predictors. One is categorical, whether a person smokes or not, and the other one is weight, which is the continuous variable. So we want basically find or predict Y with respect to using smokes and weight. So stat, regression, binary fitted line or binary logistic, both of them are fine. So binary logistic regression. So it says where is the response? By the way, we have response in resting pulse, which it says is low and high. Frequency, for the case that you have, instead of having all data, you have the summary of data, you input the frequency here. So continuous variable is weight, and categorical variable is a smoke. Okay? That's what you get. So as you can see, so this is regression. P-value is 0.023. At least one of the coefficients are significant. And as you can see, both coefficients, weight coefficient and smoke coefficients, are significant. We have R square adjusted is pretty low actually here. But R square adjusted is not a good thing for good measure for logistic regression. We have AIC, and we have individual coefficients. So this is an estimate for individual coefficients. And as you can see, this is a dummy variable. If it is yes, it's going to be 1. Otherwise, it's going to be 0. So basically, it's your p hat is exponential of beta 0 plus beta 1 x1 and beta 2 x2. The same thing here. And these coefficients are estimated here. So that beta 0, beta 1, and beta 2. Okay. So this is basically beta 0 and beta 1 when beta 2 is at low level, and this is beta 0 and beta 1 when beta 2 is at high level. So basically, you can also separate them. That's fine. I remember you had a question before regarding what are the odds ratio. So the odds ratio here is usually, I mean, it's meaningful to have odds ratio for categorical variable, but I mean for continuous variable also Minitab reports that. So odds ratio means, here odds ratio is 0.33, which means if you are smoking, okay, what is the response variable? Probability of having high, basically, pulse when you are resting, okay? So when you are smoking, odds of having high pulse is 30% more than the case, or more than the person that you don't, who is not smoking. Again, that 30% here, which is odds ratio, it can be interpreted as follows. When a person is smoking, the odds of having high resting pulse is 30% more than a person who is not smoking. Okay? And that's it. Any questions? Okay. So one last thing is, what if you have two categorical variable? So let's say you have, actually one example is gender which is male, female, and you want to see if gender is related to political choice. You have Republican, Democrats, and others, kind of like independents. And you want to see if there is any relationship between these two or not. Okay? So it's still like sort of regression problem, but both variables are categorical. So in this case, what we do, we use something called contingency table. I think I already posted the slides. I'm not going to go through details, but I just show you how perform this test. So H naught is whether these two categorical variables are independent, or H alternative is they are not independent. So there is a relationship between these two. Okay? And what you have is the number of people or samples in each cell. So it's kind of like count. How many here, how many here, how many here, how many here, and so on and so forth. Okay? So I have an example here, Minitab example, is that tables chi-square test for association to see if they are independent or not. So the test is done based on chi-square. So you select that. You can use a summary if you want, or summarize data in a two-way table, or you can say raw data. Let me find the data I'm looking for first. Here. So this is basically so this is male female, this is political choice, then so this is a summary because I have the count data. And what I do, I say, okay, column containing the table, which is Democrat, Republican, and other. And the statistics that it shows, the chi-square statistics, is the one that we are looking for. And here is the result. So these are the counts. And as you can see, the p-value here is 0.1 is greater than 0.05, we do not reject H naught, which means what? These two variables are independent. Because our H naught was what? Two variables are independent. Alternative, they are not independent. Okay? Any questions? Okay, good. So, we're almost done with Minitab, and I think what we are going to do on Friday, I'm going to be here for if you have questions regarding your project. We're going to have sort of like Q&A for project. But I want to give you written basically the exams. I think exam grades are already posted. But before that, I want to give you like 10 minutes. And and this is not basically, it's optional. So if you feel like doing it, do that. I'll give you 10 minutes if you want. Give me feedback, some feedback through the CIOS. And I'm going to leave you, and I'll be back in 10 minutes. Okay?